Okay, great. Hi, everyone. My name is Vikram, and I work for GL Communications. And thank you for attending this webinar. Um, this webinar is brought to you by GL Communications, and it is titled Voice and Data Testing Solutions for the Transit Industry. I'm joined by our Director of Consulting Services, Matt Yost, and also my other colleague, Sanjeev, is on the line. This is an ongoing webinar series that GL Communications likes to do. We try to put one out every couple months. So please, so we appreciate you attending and keep an eye out for our future webinars as well. So let's quickly begin just with the overview of GL Communications. Some of you are probably familiar with us, but some of you may not be. We are headquartered in Gaithersburg, Maryland. We also have branches in Bangalore, India, and Shanghai, China. We have been around for over 30 years. We are a telecommunications consulting company, and we also have a products division. And so we do both consulting and products. And the reason that we're very excited for this webinar today is because we'll give you a flavor of both sides of our company, both the consulting and the product side. Really briefly, our products, we can basically test many different networks, wireless networks, wired networks, electrical, optical, you name it, packet-based networks, TDM networks. We have a lot of different state-of-the-art test and measurement equipment to test these networks, and we can capture traffic, we can analyze traffic, we can do sophisticated measurements on it, and we can emulate as well. We can simulate different types of traffic on these networks. So this is just a quick company overview. Let's go ahead and get right into the agenda here. This webinar is geared towards the transit industry. It's a very exciting time for the transit industry because you have this migration from legacy communications networks to broadband networks. So we'll briefly begin by briefly talking about legacy and broadband networks and kind of comparing and contrasting the two. Then we'll talk about all the different applications that broadband networks open up. And then we'll talk about the challenges. If you're going to use a broadband network, what are your challenges, like coverage, quality, capacity, and so on. We'll get a little bit more specific when we start talking about testing considerations, testing legacy or broadband networks. What are the testing considerations? And then we'll conclude by looking at GL's products, solutions, and services. So we offer a lot of different products and services. For drive testing, we offer NetTest and VQuad, and we'll talk about all of these different products in the later half of the presentation. And we also do project management, so we can also evaluate existing networks and design and verify new networks and so on. So like I said, the transit industry is going through a transition period where a lot of legacy communications networks are being upgraded to broadband. So when I say legacy communications networks, I'm talking about land mobile radio networks. And these are ubiquitous. You basically see them everywhere, whether it's fixed route or on-demand vehicles. So buses, subways, trains, and so on. You see land mobile radio networks everywhere. And they are used predominantly for voice communication. And these networks tend to be privately owned, so the agency, the transportation agency, owns these networks. They don't have to share them with like residential customers and so on. On the other side, you have broadband networks. So broadband networks include things like 4G, LTE, 5G, and wireless networks. And so what we're seeing is some transit agencies are starting to upgrade to broadband networks. And the reason is because broadband networks can carry voice and video and data. And these broadband networks are commercially available, so it's a shared resource. The transportation agency are not the only ones using these broadband networks, obviously. So this is like just a high-level quick summary of the two different types of networks that are predominantly used in the transit industry. Let's dig a little deeper and think about legacy and broadband networks and what are the advantages and disadvantages of both networks. So first, for in terms of ownership, like I mentioned before, uh, transportation agencies own these land mobile radio networks. They don't have to share it with other customers, and that is a big advantage. It's both an advantage and a disadvantage. When you compare it to broadband networks, the commercial service provider owns the network, and it's a shared resource. So the transit agency does have to share it with residential customers. So again, that has both pluses and minuses, which we'll talk about. Um, in terms of bandwidth, these land mobile radio networks are very low bandwidth as compared to broadband networks. In terms of availability, both legacy and broadband networks have pretty good availability. I mean, if you want to place a voice call on a land mobile radio network or a broadband network, it'll most of the time go through. So they both have good availability. The differences, though, are in voice, video, and data. So legacy networks and broadband can carry voice, and they both do it very well. But legacy networks cannot carry video. Broadband can. And legacy networks carry like minimal data, whereas broadband networks carry a lot of data. So that's a huge distinguishing factor between legacy and broadband networks. Finally, there's the maintenance factor. Because these land mobile radio networks are owned by the transit agency, the burden is on them to maintain the networks. Whereas the broadband networks, because they're owned by the commercial service provider, the burden is on the service provider. What type of data and applications does a broadband network really open up? In this day and age, you basically hear a lot of buzzwords like big data and machine learning and data science. And basically, it's all based on the idea that we have so much data available to us in real time. And the organizations that can take advantage of all of this data and make predictions about the future based on the current data are going to be the organizations that succeed. And so all transit agencies have to consider like the different types of data and how much data that can be harnessed from these from any vehicle, whether it's buses, trains, subways, and so on. So let's think about that for a second. One application is fleet management and scheduling. So if you know the real-time service status of all of your fleet, you know if they're behind schedule, if they're ahead of schedule, that's all extremely valuable in terms of managing your fleet and scheduling. Additionally, these vehicles can send back a lot of diagnostic data. They can send their location back, they can send their speed, their fuel level, any errors that are coming from different systems aboard the vehicles. All of this is valuable diagnostic data that can be sent in real time to quickly identify if there's any sort of problems or security or safety concerns that are arising. Another data-enabled application is fare collection. So you can always know aboard any vehicle, you know, how many passengers you have on that vehicle. You can kind of predict if there's any sort of fare evasion. If you know the number of passengers and you know how much fare you're collecting, you can kind of detect if some passengers are sneaking aboard the vehicle without paying. If you know how many passengers you have at a given time of day or a given day of the week, you can optimize your prices, and that obviously that's very useful. Also, a lot of point of sale systems that accept credit cards or mobile payments aboard these vehicles, they need a broadband connection because they have to authenticate the credit card or the mobile payment. So these point of sale systems will really benefit from broadband connections. In terms of security, because broadband networks carry real-time video streams, you can identify security incidents anywhere aboard all of your fleet. So that's very useful. Passenger wireless services. So there, obviously your passengers, they want wireless access and internet access, so you can have your own local wireless network, and it can use a 4G modem, for instance, to reach out to the broader internet. So that's very useful. It keeps your customers happy. Advertisements, you have interactive advertisements aboard these vehicles, and voice communication, of course. So the broadband network is obviously going to be able to carry voice communication, whether this is public address systems, control systems, control centers, dispatch, maintenance, safety, and security. So these are just some of the different types of applications that can really benefit from real-time data, video, and voice streams. So with that, I'll transition to the next slide, and I'll let Matt take it from here. Matt, feel free to start.
Thank you very much, Vikram. Thank you very much. Again, my name is Matt, as Vikram introduced me earlier. I probably going to try to get into sort of a little bit of a little more of the comparison between the two, and sort of knowing that the industry is exploring and utilizing these broadband wireless networks. We're going to talk about some of the testing considerations and how to test them and how to evaluate them and so forth. Before I do that, we kind of start out here with sort of what can go wrong. And this question can be asked of your legacy land mobile radio network or new wireless broadband networks. What can go wrong? Well, poor signal strength in your area, poor video, voice quality, voice failures and transmission failures and so forth, and drops, poor bandwidth and latency. So these are the sort of the symptoms of what can go wrong. What does that when these happen, what does that affect? We're talking about the inability to manage fleets. Vikram pointed out quite a few systems and diagnostic systems and where your buses may be on their routes. So we're talking about location systems and so forth. These things will all get affected if you're relying on a network that's not reliable. Of course, increased safety risk is another consideration, and poor customer experience in general. So if some of your services are customer sort of interfacing services, and the communication between the communication network is a little bit lacking, customer is going to experience problems right away. So last thing is who is affected. We mentioned it. Passengers, and, all of your personnel. If you're at a transit agency, we're talking about maintenance, operations, police, fire, and rescue personnel. And as I mentioned, we know that the communication is critical. It seems like a very obvious statement, but a lot of bad things will happen if communication is not completely robust. So the testing considerations for the communication networks that you are using become very important. So with that said, we know the problems. We want to understand sort of the testing considerations and what should be considered. Some basic questions to ask would be, what network to test? Are we interested in your land mobile radio network, or do we need to take a look at broadband, wireless, cellular alternatives for doing different things? When to test and how often? Very important question that needs to be asked. All these things need to be part of the conversation to adequately design a test to evaluate your network. With that, time of day and month, peak times, very important. High or low passenger count situations. And then if an infrastructure component is changed, you may want to evaluate that, so forth. Where to test? Do we want to test along the entire service route, the service area, the entire route, only at your stations, maybe at stops, and facilities, in-building facilities, station, we call them facilities as well, but in buildings, in your office buildings, mobile radio coverage is important there as well. as well as if you're relying on a broadband network. So how to test, and sort of what are some of the metrics that are high level here on what we want to test and how we want to test. Coverage. So RSSI, the received signal strength indication, that very important, sort of a classic testing methodology of evaluating networks. Call and transmission failures and drops. The quality. People in the radio world are familiar with something called DAC, which is delivered audio quality. These things are important. In the telecom world and telecommunications industry, we somewhat usually refer to it as voice quality, and we use ITU industry standard algorithms, and the latest are Polka and PESC. So again, these are evaluations of voice quality across your network. And what's the capacity? What's the bandwidth? What's the throughput bandwidth? What's the uplink and downlink considerations there? All, again, important questions to ask. So concerning the testing methodology, just a little bit more, what test devices and services are needed? It needs to be versatile. It needs to be able to test your radio network if that's what you want to test. It needs to test 4G, 5G, network, wireless broadband network, or maybe the network core. Maybe you have fiber that you need some testing on, and you want to make sure that your core is in good shape. It needs to be portable or stationary, or that's the question. Does it need to be portable or does it need to be stationary, or both? Flexible, cover many KPIs. KPIs stands for key performance indicators. So what we're talking about there, again, is some of the things we mentioned: the RSSI, your call and voice transmissions, the quality of that voice, the latency of the network, and the bandwidth and throughput of that network. All things need to be considered if you want to rely on that network to provide a service to your customers and to your maintenance people and people of operation. So we need to be able to facilitate the root cause analysis with the testing device and service. And it's very nice to have automation with your testing device and service. So minimal interaction or supervision. A repeatable testing methodology is very important here. We want to have very good confidence in the results, and we don't want to ever ask the question, did a human mistake cause an abnormal result here? So the automation, the repeatability is very important. Objective testing. It seems obvious, but the test equipment or the service should be very objective. And we'll talk a little bit more about that. It should be easily used, and it should obviously be cost effective. So with this next slide, we're kind of jumping right into sort of examples of some concerns and important questions that customers of GL in the past have asked us to help them with. So we just figured we'd jump right in here and give you some very specific things and show you sort of some of the capabilities on how we were able to help answer these questions. Number one, which broadband service provider is the best in my area of operation? Maybe you're considering moving some service or some element of your service offerings or to broadband wireless, so commercially available broadband wireless. Well, you'd want to know in your service area, in your area of operation, which commercially available wireless provider is meeting your expectations. So we have ways of comparing the Verizons versus the AT&Ts to the Sprints and the T-Mobiles and so forth. And when I put it in quotes, the word best is a word that it doesn't have a very good definition there, but when we're designing the test and we're figuring out what service you're planning to use or what service you're planning to provide, the definition of the test parameters become very important. Do we need to test for voice? Are you going to be using voice across this broadband service? Is it all data, and so forth? Number two on our list is, what if I add new service, okay, or new service area? is the existing network infrastructure adequate to cover the new service area? So this is a question that can be asked of a land mobile existing network. If you're maybe changing bus routes or adding an extension to a rail line or something, you want to know, does my land mobile radio network, is it going to be operational in this new area? Very important. And it's important with a broadband wireless carrier as well. Maybe you're in a rural area and you want to know if you can rely on that broadband connection. Number 3 on our list is the network consistently performing over time in a way that's sufficient to handle operations? So we've been asked to sort of over time and in an intrusive manner consistently test the network to alert a customer, to alert our customer, I mean GL's customer, if something is going wrong or if there's problems. So that's a specific question that we've been asked. And the last one is, what is the network performance within my tunnels? Okay, so as a transit agency, you may have tunnels in your metro or and so forth. Do you want to provide service in your tunnels, whatever that service may be? If it's operational, your radio operations, the answer to that's most likely yes. If it's providing your customers on your trains wireless connectivity, it may be yes, and maybe yes in the future. So all of these things have been asked of GL in the past, and we wanted to list them because we think they're fairly common issues, and we think that these things should be considered when deciding to move operational systems to broadband wireless networks. So with that, I'm going to dive in a little bit deeper on how we've answered these questions. Here's an example of GL providing a service, test equipment, and a service where we evaluated an LTE network, actually multiple LTE networks. So the first question I asked in the previous slide was, which broadband service provider was best in my area? Well, this is an example of a service that we provided here at GL, where we tested Verizon versus Sprint and AT&T. And we tested it for received signal strength indication, where what's the coverage looking like in the area. We tested it for TCP data throughput and coverage dropouts. A slew of other KPIs were tested here. So the customer in this case wanted to use a broadband wireless provider or multiple, and they wanted to know which one was the best one in their area. So we were able to come in, work with that customer, design tests to adequately evaluate these commercially available broadband networks, and test for the parameters that were very important for whatever that service was that transit agency was providing. And what we did in the end of it, we went out, we did a lot of, we call it drive testing, but we rode buses and so forth. And that can be done in a manned fashion, where we can take the test equipment with us and we can man it, or we can work with the agency to put some of our equipment on the bus or on the train in an unmanned fashion, and it can just be collecting data over time. All of that data is brought back to us, and GL analyzes, again, works with the customer on what's important, what's not, and compiles a report. In this particular case, we recommended two wireless carriers to this customer and evaluated multiple. One example. Second, new service area. This was an example of a customer who wanted to test their land mobile radio network in a new service area. Is their existing infrastructure adequate for this new service area? That was the question. So we were able to go out, do a lot of drive testing where we evaluated RSSI as well as DAQ, so uplink and downlink delivered audio quality. specifically what we did was we broke the service area into quarter-mile grids, and we tested many points of test within each grid, and we recommended well, we worked with the customer to recommend what the test would be. It evolved down to RSSI and DAQ, and our recommendation was provided to the customer. And you can see here, if you kind of look closely, the quality was pretty good in all the area. The gray area, gray blocks are areas that were not accessible because of no roads, lack of roads. Okay. Another land mobile radio test that we performed for a customer was, and this one in particular, was riding a train route. And it was a land mobile radio test to determine, again, RSSI and delivered audio quality on an existing land mobile radio network. So we verified coverage and identified any anomalies and so forth, and how the system was performing, and provided a report. Again, this is an area where our equipment that we have and provide our service can be provided, where we bring people out to do the testing for the customer, or we can bring equipment out and install it on a vehicle and let that vehicle run its normal service route, or if it's a train, its normal routes, and we can be collecting data. Okay. Just one other example of that. This one in particular is a voice quality and call connectivity test around the Washington Beltway, DC Beltway. So it's just another example of what we've done here. This particular test was voice quality. So in this case, we were using commercially available and ITU standard voice quality algorithms, referred to as PESC and Polka, and we were testing. So we were testing for voice quality, and in this particular test, you can see we were testing for data throughput through some TCP testing and so forth. Okay. All right. One example here that I wanted to put up for the transit agency is, tunnels in metros and so forth are very important, and GL has performed a lot of testing and is currently doing ongoing testing to determine if the land mobile radio system within the tunnel is performing at the expectation of the customer. So we have the ability to do uplink and downlink testing with your land mobile radio system, and to evaluate it and to report if there are any outages. Maybe a bidirectional antenna or amplifier is having some problem in your tunnel. We would see that with our plots, with our RF receive plots here that we're showing. This is one example where you can see we have a plot between station 1 and station 2, and we have some chain markers that we're identifying different events with the received signal strength of that. This is an uplink plot. We also do downlink plots as well. The infrastructure can be radiating cable or BDAs installation. So, and when to test in this situation, customers have come to us for ongoing testing to provide them this service so that they can act quickly if one of their BDAs is down, or they've come to us when they've had some changes in their network. So maybe they've made some adjustments to their network and they wanted us to come through and evaluate that. And also on here is migrating to a new frequency. Some transitions are happening in the industry, frequency transitions and so forth, and we're able to come in and evaluate these new frequencies if needed. One last example, sort of your traditional propagation plots. GL has the services and the software to provide that for you. So that can be sort of as-is condition of what's going on right now, or prediction plots for future if you if you're adding sites and so forth, we can provide prediction plots there. Again, when you're adding sites or changing equipment or migrating to new frequencies, these things become very nice tools to provide to customers so that they can get some assurance of what's going to happen. Lots of input considerations to these plots and to this software: the frequency, the power, etc., and the terrain or the foliage building losses is all part of that. So now we've kind of gone over a lot of the services and what we've provided, but the question now becomes, like, what equipment or test gear can make these tests that I've talked about possible? So Vikram had mentioned earlier about GL is a consulting services company as well as a products company. So we're taking a lot of our products here that we design, manufacture, and sell to the commercial telecom industry. We're taking those, we're using them and applying them to the transit industry through our services. One of those such products, and we wanted to just mention them, one of our such products we call the VQuad probe. And the VQuad probe is a piece of hardware that it can connect to cell phones, any device basically that has an audio interface to it. So cell phone, a radio, a land mobile radio, push-to-talk radio, analog phones, new VoIP phones, anything that has audio, we can connect to it with this device, and thus we can send and record voice through the device, through the network, and evaluate the quality of that voice. All results when doing that are sent to a central database, and we can provide sort of real-time analysis and real-time viewing of what's happening in your network. Or we can provide post-process analysis, so we can collect data all night long. We can come back and we can take a look at that data and provide reports and so forth. Very adaptable and very user-friendly. It has the ability to be completely automated, so no person is required when using the device. It's remote accessible, so you can log into it, check it, and so forth. It can do a lot of different things. We provide RSSI, delay, echo, full array of audio metrics, and I'd mentioned previously about voice and the voice quality algorithms. We mentioned them here. PESC and Polka are the two. These are, if you haven't heard of them, these are industry standard telecom algorithms to evaluate voice quality in networks. So this device, the VQuad probe, comes from our product side, and we utilize it to service transit agencies and so forth, and we can send our crews out and we can test networks with this device and provide reports and so forth. Or if you want to just purchase the device and use your own crew to test, we do that all the time as well. So that's what this VQuad probe does. The next thing of mention is something called the NetTest, and what this is a mobile application. And it's a mobile application. Of course, it supports iOS and Android, and it has the ability to, so when we're evaluating these broadband wireless networks, we can install this NetTest application on your phones, our phones, and we can do all types of data testing through the network and evaluate them. It can be 4G, 3G, LTE networks, all of the metrics I've mentioned there. TCP, UDP testing, email, SMSs, so forth. Again, central database is involved, so our testing methodology does not change between these devices. Everything's collected, sent to a central database for analysis and reporting. And again, very automated. So scripting is there. You can set it up. You can let it run. You can put it on a bus. You can put it on a train, and it will run and do its testing along your service routes. Okay. Some other equipment that we're very trained on, and we have in-house many of these. In addition to these, we have many others. We have frequency receivers. So we're able to use these log RSSI values at defined intervals and provide those plots. Spectrum analyzers, very familiar with those, and GL's service group uses them all the time for uplink, downlink testing and so forth, as well as RF transmitters. So we have devices that can act like your portables and your mobiles and transmit certain frequencies, whatever we're trying to evaluate at the time. So all this equipment, if it's homegrown, meaning GL has provided it and made it from scratch, basically providing it to the commercially available commercial network there or commercial customers, we're able to use those homegrown products as well as other equipment that we have acquired over the time. So in conclusion, just want to kind of go over a little bit here, and then we can have if anybody has any questions for us, we can talk about it. Transit agencies should harness broadband networks. We know that they're here to stay. Wireless broadband networks are going to be the future for everything. Transit agency is no exception to that. It's going to help with improved fleet management. It's going to reduce your safety risk, and it's definitely going to enhance customer experiences in a lot of ways. The challenges include, the coverage, the quality, and the capacity, as we talked about a little bit. And we think that with those challenges, the testing considerations need to be very, very carefully considered. We're in the arena of doing testing. We think we can sit down with you as a transit agency or somebody representing a transit agency or something providing a service, and we can talk about design tests to help evaluate some of these networks for you. We offer many solutions that allow transit agencies and operators to test and measure performance. As we mentioned there, we just provided a few small examples. We have many others that we've done. And we offer the analysis, the planning, design, inspection. So in addition to a lot of the things we talked about today, GL is with its consulting services division, has provided services to transit agencies in a lot of different areas that span to PA testing at your stations, on your vehicles and so forth, to project management at a call center. Maybe you operate a call center, and we've done a lot of project management and expert technical requirements analysis for call centers and so forth. So we do a lot in the communications world. Mainly our consulting services are related to communications, but we branch out a little bit. So that's the conclusion of it. I hope everybody enjoyed themselves. And we wanted to take a time to just kind of go over this at a very high level for you. And we know that a lot of agencies and a lot of related people out there are considering these broadband networks. So we thought it would be a good topic. We hope that it shed a little light on some of the considerations for testing those networks. And at this time, we'll take some questions if there are any.
A couple of questions we have got. One is, can you use our own radios to interface with the GL equipment rather than using the GL radios?
Yes. So products that we have in the equipment that we use, we try when we're designing these tests, we want to use your radios, your equipment. So that can be let's say your portable radios, your mobile radios. We can interface to those radios through that VQuad probe that we showed you. If you're providing a service maybe in a bus or a train that uses a broadband network, and you have a broadband wireless router, we can test it. We can test the network through that broadband wireless router through a variety of ways as well. So in general, we try to use the equipment from end to end that you already have. So the answer is yes.
Okay, thank you, Matt. One more question is somebody is asking whether we support scripting like automation and all. Is it possible?
Yeah. So yeah, I think I mentioned it a little bit, but it is important that you have some scripting abilities with your test equipment and with the services provided there. It does a lot of things for you. It provides you, it allows a repeatable test. I mentioned earlier that you want to take the human element out of the testing. You never want to be asking that question: was the testing due to uh, you know somebody's lack of knowledge of using the test equipment, or did they put the antenna in the same place every time? Yeah, there's a lot of questions there that can be that can shed some doubt on the tests. We try to eliminate those as best as we can, so we're trying to do everything with automation and scripts. So yes, we do that with our products. Okay.
Yeah, I think that's all
Okay.
from the question answers.
Okay, if there are no more, we thank everybody for coming. Vikram, thank you for everything. Do you have anything else at the moment, Vikram, to say?
No, thank you, Matt. That was a fantastic presentation. Just to close out, you can contact Matt Yost directly at myost@gl.com. And like I said, this presentation will be made available on our website, so you can come back and we'll send an email when it's posted. So thank you, everybody, for attending, and please don't hesitate to reach out to us. Thank you.
Thank you, guys. Everybody, thank you.